Alright, so I think this is recording. Let's take a look at these rational functions. We're finding the intercepts, the x-intercept, the y-intercept, the end behavior, the vertical asymptotes, if there are any, and any holes if there are any. So I guess we should say that for x-intercepts and y-intercepts, they may not exist either. So let's find the y-intercepts by letting the y-intercept by letting x equal 0. F evaluated at 0. Well, my numerator is 0, but so is my denominator, so that's undefined, and there is no y-intercept. If we take a look at to find the x-intercepts, we let y equal 0. Y is the output of the function. That's the left-hand side of this equation. So I need to focus my attention on the numerator. However, because I have variables in the denominator, I'm concerned about division by 0. So let's factor this. In the numerator, we see the greatest common factor is x. So we've got 10x squared minus x minus 2. And here I have a greatest common factor of x. I have 25x squared minus 4. Alright, we can continue factoring this. So with 10x squared, I either have 1 times 10 or 2 times 5. Let's try the 2 times 5. Now with the 2, it's a prime number, so I've got 1 and 2. Now one of them needs to be negative. I need the value that's going to give me the larger in magnitude to be negative. So if I have negative 1, that'll give me a negative 5. If I have plus 2, that'll give me a positive 4, so I'll get a middle term that's negative there. So this is how, and if you need to, you can, I don't know, factor by the x method, or there's a Berry method. There's tons of different methods that teachers apparently have shown people how to do the distributive property. Alright, so here, these are both a difference of perfect squares. So I've got 5x plus 2 and 5x minus 2. Because 5x squared is 25x squared and 2 squared is 4. So I want to be careful when I look at my x-intercepts. I don't want to call negative 2/5 an x-intercept. It's going to be a hole in the graph. I can now look at my numerator and x also. This we already said that it had no y-intercept, so there's no way that it would be going through the origin. So the only x-intercept that we have, 2x minus 1 equals 0, well, that's just a two-step equation. Add 1 to both sides and divide by 2. So this graph intersects the x-axis only at one place, at x equals positive 1/2. It had no y-intercept. When we get to later on, we're going to see that we have two holes in the graph, one at the x equals 0 and one at x equals negative 2/5, and we'll have to plug in those values into this reduced expression to find the y-coordinate. So anyway, no y-intercept. This is the only x-intercept. Let's move on. In behavior, the degree of the numerator is 3. The degree of the denominator is also 3. When you have the equal degrees, you have a horizontal asymptote, and the equation of the horizontal asymptote, remember it's always a line, is y equals a ratio of the leading coefficients. The number in front of x cubed was 10. The number in front of x cubed here is 25. Those both share a common factor of 5, so this reduces to 2/5. So there's my in behavior. some students may prefer to write as x is approaching negative infinity, y is getting closer and closer to this 2/5. As x is approaching positive infinity, y is approaching this 2/5. So either one of those is an acceptable answer to describe the end behavior of this rational function that's in problem 4. What about vertical asymptotes? If we factor the numerator, we said that we had 10x squared minus 5x plus 4x is minus x, and positive 2 times negative 1 is a negative 2. Here, if I factor a common, the least or the greatest common factor of those is x, and then I have 25x squared minus 4. That's a difference of perfect squares, and that factors to 5x plus 2 and 5x minus 2. So these common factors in the numerator and denominator cancel, and I have one vertical asymptote. This factor that remains in the denominator, if you set it equal to 0 and solve that for x by adding 2 and dividing by 5, we know that the vertical asymptote is the line x equals 2/5 x. The line x equals 2/5, 2/5. Now it wants us to identify any holes in the graph. We have 2 holes. We want the location of those holes. Well, one of them is going to occur here at 0 and the other at negative 2/5. We need to plug in those values into this reduced expression and see what we get. This reduced expression, 2x minus 1 over 5x minus 2, if we allow 0 there, we have negative 1 divided by negative, we've got a positive 1/2. Then for negative 2/5, what do we have? Well, let's negative 2/5 minus 1, 5 times negative 2/5 minus 2. So the numerator, I have negative 4 over 5. I'll rewrite 1 as 5 over 5. In the denominator, these 5's cancel, and negative 2 minus 2 is a negative 4. And in the numerator, negative 4/5 minus 5/5 is negative 9/5. That's being divided by negative 4. Well, the negatives cancel. So this 9/5 to divide by 4 is the same as to multiply by 1/4. And I'm getting a y coordinate of 9 over 20. I'm getting 9 over 20 here. So I believe that's all we need for problem 4. So I hope that helps.